In the early hours of January 3, 2025, at exactly 3:15 a.m., the Kapistan Yar strategic missile testing site powered up for a routine diagnostic. Deep inside the complex, a Russian engineer initiated the cryogenic pre-chill sequence standard procedure before system readiness checks. But according to Ukrainian intelligence accounts, that simple diagnostic opened a rare, high-value window. For 48 continuous hours, Ukrainian reconnaissance teams had monitored the site, mapping guard rotations, radar patterns, ground vehicle movement, and the timing of silo door operations. They were waiting for just one thing: the moment the giant steel doors would slide open, exposing the missile's support architecture conduits, cooling systems, control housings, the fragile organs of a structure usually sealed behind layers of reinforced armor. When the massive doors finally separated, that became the signal for a small strike team armed not with jets, missiles, or artillery, but 4 improvised FPV drones. Cost of each drone? Around $500. Value of the Russian launcher they were targeting? Nearly $100 million. The plan had been rehearsed for weeks. Ukrainian SBU intelligence and a special SSRU operations element coordinated the mission down to seconds. The goal was not to destroy the missile itself, but to disable the system and force pressure points inside Russia's air defense network. 3 miles from the silo, 2 SSRU vehicles intentionally collided to simulate a roadside traffic accident. The staged crash blocked the main access road. Meanwhile, 4 OSA series FPV drones, each fitted with a compact-shaped charge, lifted from a concealed compartment and climbed into dense early morning fog. The fog acted as natural electronic camouflage, scattering radar beams and limiting both optical and infrared visibility. At exactly 3:15 a.m., the engagement began. OSA-1 flew directly toward the inner perimeter, deliberately exposing itself. The drone's mission was sacrificial: provoke the Russian electronic warfare suite. Within seconds, a Kaskoka 4 EW unit detected it, locked on, and severed its control link. Video feed died instantly. But this loss was intentional. The jammer had revealed its frequency band and directional main lobe critical data for the remaining drones. Moments later, OSA-2 climbed sharply, widening its radar profile to act as a decoy. The maneuver worked. An S-400 battery located nearby responded with a 48 N6 surface-to-air missile, obliterating the drone mid-air. Ukraine had traded a $500 drone for a multi-million-dollar interceptor and, more importantly, forced both long-range air defense and the primary EW system to engage simultaneously, creating a brief but crucial opening. With defenses distracted, OSA-3 and OSA-4 pressed forward into the short-range kill zone, guarded by Tor-M2 and Pantsir S-1 systems. Tors rather detected OSA-3 at a distance of 5 miles, launching a 9M331 missile to intercept. In response, the Ukrainian operator plunged OSA-3 into the fog at near ground level, using terrain clutter to break the missile's guidance lock. The incoming missile lost its target and self-destructed, but luck didn't last. The Pantsir S-1 switched from precise tracking to a wide spray of fragmentation missiles, saturating the air with shrapnel. OSA-3 disappeared in the explosion. That left OSA-4 already hit by near-miss shrapnel. Video feed flickered, audio crackled with wind distortion, and one motor began failing. The drone drifted right, unbalanced. At that moment, the pilot, known in the transcript by callsign Koval, made a desperate adjustment. Instead of fighting the damage, he used it. Guiding the malfunction, he forced the drone into a tight, spiraling corkscrew descent, slipping behind parts of the silo superstructure to break line-of-sight targeting. The Pantsir's computers lost their firing solution. When OSA-4 re-emerged from the blind angle, it was already locked onto a vulnerable cryogenic feed line. At 3 hours 15 minutes and 47 seconds a.m., the shaped charge detonated. A 5-inch cryogenic conduit ruptured, releasing a surge of supercooled refrigerant, reportedly liquid nitrogen, onto it.
Ukraine's army is bleeding at a catastrophic rate. Tens of thousands have abandoned their posts. Reports from the front line say that entire units are vanishing from defensive lines. And on the Eastern Front, Russian forces are advancing at the fastest pace in over 2 years. The brutal mathematics of attrition warfare reveals a crisis that threatens Ukraine's ability to hold the line. Here's a report.
Adjacent systems. The thermal shock slammed through the machinery, warping metal, cracking welds, and stressing circuit boards. According to Ukrainian sources, the cascading short circuit triggered a non-nuclear sympathetic detonation within the warhead handling bay, deforming the launcher and producing a small seismic reading of 1.9. When the fog cleared, the once intact launcher stood mangled, an 80-foot twisted mass of metal. Debris from destroyed defense systems littered the ground. Ukrainian reports highlighted two operational effects. First, the loss of a launcher that Russia could only replace in limited annual numbers. Second, the sudden creation of a gap in a major air defense coverage zone. Communications at the facility dropped for hours. Diagnostics were halted at other bases. Russia publicly dismissed the event as a training mishap, but satellite imagery and local social media contradicted that claim. Ukraine framed the strike as proof of a new warfare principle. Inexpensive systems, when coordinated, can breach even the most advanced infrastructure. 4 drones costing roughly $2,000 total had disabled an installation worth over $100 million, along with forcing Russia to waste expensive interceptors and reveal classified EW patterns. But the narrative did not end there. A second operation conducted against a mobile Kaskoka 4 EW convoy followed the same low-cost, high-impact logic. The compromise began not with a radar ping, but with a soldier's casual social media clip showing the convoy's location. Ukrainian cyber teams extracted GPS metadata from the video. Without emitting any detectable signal, they built a precise targeting package. At 3:30 a.m., the deception began. 5 Banshee jet-powered decoys climbed high and broadcast fighter-like signatures to draw surveillance radars upward. Meanwhile, 10 FPV drones skimmed the terrain at low altitude, running inertial navigation combined with a visual recognition model for the EW truck's antenna array. A Tor M2 engaged the decoys, shooting down 3 and providing Ukraine fresh tracking data. Russian naval infantry tried to jam the incoming low-altitude drones, knocking 2 offline. But Ukrainian electronic support teams, having recorded the Tor's emissions, cued a digital sniper drone to blind the Kaskoka 4's receiver with targeted saturation noise. With the EW truck sensor suite overloaded, 7 FPVs continued silently toward the convoy. 3 others were redirected to suppress infantry positions that had exposed themselves through gunfire and jamming activity. Minutes later, a Beriev, a 50 AWACS aircraft arrived and relayed targeting data to the Tor, prompting another missile launch. But one FPV drone deployed a fiber-tethered radar enhancer, essentially a tiny decoy reflector that lured the missile off course and detonated it harmlessly. At 3:36 a.m., 6 FPV drones converged on the primary Ural 4320 EW vehicle. Using the antenna structure as a visual fingerprint, the lead drone punched through an access gap and detonated its payload inside. The resulting overpressure, fragmentation, and secondary fire knocked the system offline instantly. With communications severed, escort coordination collapsed, and armored T-90 seconds and BMP 3 seconds suddenly lacked electronic protection. Fuel trucks stalled. Ammunition transports halted. Ukrainian forces pressed a counterattack. Both operations at the fixed silo site and against the mobile EW convoy demonstrated the same principle: isolate, distract, measure, and strike the critical node. The battles reinforced a troubling cost imbalance for defenders. Every expensive missile fired, every radar mode activated, every EW burst transmitted gives attackers priceless data at minimal cost. The transcript ends with an open question for the future of modern warfare. As small, cheap drone swarms gain precision, adaptability, and intelligence, will they continue slipping through layered air defenses? Or will improved sensor fusion, faster handoff systems, and advanced counter-UAS tactics finally close that window of vulnerability? Only the next battlefield will answer that. If you want more deep-dive breakdowns like this, real operations, real tactics, and real battlefield innovation, make sure to subscribe to Tactical Signal. New analysis drops every week. Stay sharp, stay informed.